All right, so today's lesson is talking about concavity. You have a graph, and either the graph is concave up, concave down, or neither. Here are examples of concave down graphs where the slopes are decreasing. Um, Often, concave down graphs would be known as spilling water. Concave up graphs, on the other hand, hold water. And notice their slopes are increasing. So those are examples of concave up and concave down. Here is the graph of a function, and notice the graph is concave up from here to here. And then the graph becomes concave down from here to here. When you have a change in concavity, at that point, you're known to be working with inflection points. Notice here is a graph of the sine curve. The tangent line, when the graph of the function is concave up, notice how the tangent line to the graph of the function is below the graph. When the graph is concave down, notice that the tangent line is above the graph. And it's making a switch right at that point of inflection, where you have a change in concavity. So, what does that mean in the world of our notes? Well, definition of concavity. Let f be differentiable on an open interval I. The graph of f is concave upward on the interval, and we're focusing on this interval. If f prime is increasing, that would mean f double prime is positive. The graph of f is concave downward on an interval I if f prime is decreasing. Again, you have to make sure that we're talking about f prime, or if we were talking about f, we would want to be working with the second derivative. So let's take a look at this sheet. Let f be a function whose second derivative exists on an open interval. If f double prime of x is greater than 0 for all x and I, then the graph of f is concave up. For f double prime of x less than 0 for all x and I, the graph of f is concave down. Let's look at y equals x squared. You know in your heart that that graph of the function there is concave up everywhere. Well, if I took the first derivative, y prime is equal to x. Here our slope is increasing, so we see why it's the graph of f, or y equals x squared, is concave up. Notice y double prime, that's 2x, sorry, and y double prime, there would be 2. If our second derivative is positive, the graph of the function is concave up. Hope that helped.